how's everybody doing? My name is Dan Edelman, and welcome to another Beyond Our Value Roundtable edition. So today we're going to be going passive, and with that, we're going to be actually talking to some industry leaders in this category. So we have some folks on here. We're going to go around and do introductions. First and foremost, I'm going to introduce myself. I'm Dan Edelman. I've been with TimberHP now for over a year. And then I'm going to pass the mic over to Paige.
Hi, I'm Paige Malloy. I've been with TimberHP for a little over a year and a half, based out of New York, and I'm here to assist.
Yep. Thank you, Paige. And Paige will also be monitoring the Q&A. So if you guys do have any questions, by all means, just simply pop them right into, oh, hey, Dan. Just pop the questions right into the chat or the Q&A, and then we'll basically get to them live, or she'll wait to bring them up at the very end and we'll go through them. But today we're talking Passive House. So I'm going to go through the panelists now. We do meet every third Thursday of the month typically, and it's a roundtable. So it's a very unique forum that we have here. We have industry leaders from, basically a northern climate, a central climate, and a southern climate. And we basically discuss different topics each month. So I'm going to start with our panelists now, our industry leaders. So I'm going to start down in the south with Chris Walmer-Giddens. So Chris, quick introduction, please.
Hey everyone. Yep, Chris Walmer-Giddens with LG Squared. We are an architecture construction consulting firm, designing and building high performance passive buildings, and helping certify through Passive House or just building rock star buildings. We work all over the country, but are based in Atlanta.
Awesome, and thank you for joining, Chris. And then moving north, next is from Washington, D.C., one of my good friends, Dan Hines. Dan?
Hi, everybody. I'm Dan Hines. I am the Director of Construction for Habitat for Humanity of Washington, D.C. and Northern Virginia. And we've had the pleasure of doing a number of FIA certified passive houses in the past, and are planning for a big 17 home development coming up here soon. So excited to talk about this.
Awesome. And thanks for joining, Dan, especially on Passive House. And last but certainly not least, and who's going to be running the presentation at the beginning here, Randy Rand.
Yeah, so I'm Randy Rand, up here in Orono, Maine. I'm a builder, certified passive house tradesperson, soon to be hopefully certified consultant. I also am the training director for Passive House Maine. We provide training and education statewide on high performance building, meeting energy codes, and passive house to all parts of Maine. And we have a traveling roadshow that does that. So that's my background.
Awesome. Thank you, Randy. And for all you out there, thank you very much for joining once again. Again, this is the Beyond Our Value. TimberHP is a wood fiber insulation that's out in the market right now. And today we're going to be talking about Passive House. What is Passive House? Differences in climate zones that you really need to hit when looking at Passive House, but also just finding some cool tips and tricks that you can kind of pull from Passive House, even if you're not necessarily building a Passive House, but just good ways of basically building better and integrating those ideas into your next project. And at the very end, we'll go through final thoughts and Q&A. I am going to actually get started, though, with a little presentation just about TimberHP. The first part is where we're sourcing our materials. We're based up in the state of Maine. We're taking wood chips from FSC and SFI certified forests, meaning the forests that we're actually pulling the wood chips from are sustainably harvested. I think Randy Rand probably definitely lives the closest out of anybody on here to these, but that's just something pretty neat. All we're doing, we're taking those chips, the waste chips from the lumber mill industry. We're basically steaming them, shredding them, adding a liquid boric acid, and that creates our timber fill product, our blow-in product, then our timber bat. And then we also will have a timber board product. I know Dan Hines is very excited about that product. I think he calls me about once a day asking when it's going to be available. So it will be soon. It will be soon. We're saying June or July at this time. So it's now November. So when we start looking at the carbon and embodied carbon, and guys, feel free to chime in too during these, because I know you guys also do a lot with carbon. I'm not sure how much is in the presentation of carbon. But basically, insulation is a big area where we could really reduce carbon that we're putting into our buildings. Concrete, number one, there are ways to reduce the amount of concrete in a build, but insulation really without much of a cost premium also is a great way to really reduce that carbon. When we start looking at different products and everything, you can see obviously the wood fiber were negative carbon. And then when you get into like the foams, it's going to be much higher. I'm going to go to the end here, but basically if we look at a passive house wall, we could save a lot of carbon here. This is basically showcasing that, you could, by using wood fiber insulation, you're basically able to take a car off the road for 2.5 years based on the carbon, which is a really nice benefit. And then, Chris, I wanted to kind of pass it over to you to talk about what you're building now in your world.
We're building a house that's going to float up into the sky. This is a this is a little weather balloon right here. That when the owners want to just go for a little ride, they'll take off. This is a new construction home in Atlanta. We are going to be certifying it passive house, the 2024 criteria. It's about a 4-bedroom in a historic area of Atlanta. So we're going for a craftsman to fit within the context of the neighborhood there, and it's pulling out all the stops, getting it, we're doing a continuous insulation on the exterior, and then we're going to use a blown-in product, most likely in the cavities, all the cavities, and in the attic and on the roof line. I'm going to button this up real tight and use some, trying to think. Yeah, we don't have to. Of course, we're in the South. We're able to do this without triple pane glazing, but we'll get into some of that when we get into some of the details of this project and the process. And a lot of this is, this looks like you can have a normal looking house and still have it be passive. Nothing has to be tricky about it, but there it is. It's breaking ground this January.
Awesome. Yeah, and I think I do have some questions about some of the details that you're going to be going with some of these roof systems and all that, but I did want to get into Randy's and just talk about what passive house is before we kind of dive into that. And Dan, feel free to jump in also. During his presentation, we like to interject during presentations and do that. So do you have you can take control of the screen? There you go. And we can see your screen, Randy.
All right. Well, I can't. Hang on. There we go. So I think the first thing we always start is just what is passive house. So thinking very simply, right, and trying to just get it out there to everybody, is it's a set of design standards basically, and then we've developed methods for building. So it's like a building code, but it's a design standard and methods for building, where the ultimate goal is interior comfort, health, and like predictability of how that building is going to operate, right? And who doesn't want to have a comfortable home or a place to be in, right, all the time? So those are the main things. And I think it's always been one of those things that it's hard to add value to when you start talking about some of this stuff. So it is a hard sell sometimes. But those standards, And the certification process is done with two different agencies here in the US. So there's the original German-based Passive House Institute, and then the US-based FIAS, Passive House Institute US. Both organizations also have certifications for new builds plus for retrofit. So if we're looking at doing a retrofit, you still can modify that house to meet Passive House standards. So that's kind of cool.
And
Um, ooh,
Dan, which one did you use? Which
We
standard do you-
typically use FIAS, and there's not, I'm sure if we got into the nitty gritty, people can disagree one better than this or that. It almost becomes like a political or religious affiliation for some people, but they're both great organizations, and I think you end up with a really great building. If you went into it with the design for one, you might need to change some things for the other. But most of ours, we do FIAS. And honestly, the reason for that is that's just who we teamed up with the first one that we did. And it's easy once you get to know the people doing the evaluation of your designs and the ins and outs of it. It just becomes something where it's a little bit easier once you pick one. But I know there's some people that bounce back and forth, and they're both great programs, I think.
Awesome. Thank you.
yeah. Yeah, and they're all kind of based on the idea of designing your building, using the appropriate software with from that organization, submitting, building, and then the big part that I always that we should find more value in is the verification process. So all these organizations have a way to verify that your building was actually built to the standard that you designed it to. So.
I think one more thing to add there, Randy, is just that this program, like any other, the building program, they're all volunteer. None of this, you mentioned code, but this is a volunteer. They were all set up to help the construction industry, the builders, do better, and they volunteer to have a guide. And this is just now we're getting into the most strict of all that have been. And so now building codes are starting to make requirements, but only internationally. And I guess some up north are starting to, like New York, I think, is starting to consider it. But it is just volunteer at this point mostly, and it's a really good path, though, even though it's not yet required.
Yeah, and I think one cool thing that we're seeing on that requirement side is that we'll start to see, funding for, government projects and different types of those funding sources are going to start requiring a standard like Passive House or something better or not something better. It is the best, but in my opinion, and but yeah, tying funding to some of these standards because they know their money's gonna last longer. So, but when we think of Passive House, I think a lot of people have always just leaned towards that home, that single family residential building. But there is no limit to Passive House. It is any building. It can be a, high rise that has a lot of glass. It can be schools, offices, any type of building we can build to a Passive House standard. So, but I think it's just over the years have had that stigma of a pretty plain and ordinary residential building. But as you saw, even with Chris's upcoming project, it doesn't need to be that plain box. So that is pretty cool. So what are the standards or the targets that we're trying to meet with Passive House? So it sets forth just really simply a couple design standards that we're trying to hit. One being thermal energy demand, so the total heating and cooling load that's required to keep that building space conditioned to that comfort level that's set forth, right? And then also total energy demand, so overall, the plug loads in the building and all that. And the other big one is the air tightness. So air tightness tends to be one that we talk about quite frequently because no matter what climate zone we're in or what we're trying to design with different wall assemblies, air tightness standard is, the same everywhere, and everybody's trying to, detail things out to that extra effort. Um, but what do we look at when we're looking at, meeting those standards and we're beginning our design? So things like continuous insulation is very important, reducing those radiators from the exterior to the interior spaces, right? By covering those studs up in the walls with continuous insulation. Eliminating thermal bridges is a big thing, and very important, especially when we start talking about like moisture in walls and condensing surfaces and problem spots. Once we start controlling everything so much better, even a smallest thermal bridge could be a problem in the long run. So we look at those very, very closely. Air tightness, high performance windows and doors really make a big difference. And then fresh air. So mechanical ventilation is a requirement, for all these passive houses, and it just increases the quality of our air inside, right? And saves energy. So it's something that I think we're starting to see with like code in our area, people starting to talk about it. But that's what's kind of cool, I think, about passive house. And as we start talking about these things, they become a little bit more mainstream and they start trickling down into code built homes and things like that. So everything from air tightness to mechanical ventilation is really starting to affect the industry wide. And those that have been in the passive house industry are the ones that we're seeing, lead the change going forward, because most of us are very open, willing to share and help everybody else, because our main goal is to better the entire built environment. So but you can see a few of the other things that all kind of matter as we go into designing a passive house. Nobody else wants to chime in?
Hey, Chris, I remember that you had lighting solar gain awnings on your Marietta house, but that was not a passive house, correct?
Correct.
Okay.
There,
But you said that.
there's an interesting thing about awnings, in the South, this, there's this reputation of, oh, we need to block all the sun in our buildings. And with the FIAS, with their prescriptive path, which is, by the way, more difficult to achieve and can cost more. That's just the trend, or that's the research has shown that. But if you follow the prescriptive path, if this is, say, a 6-foot window right here, if this is a 6-foot window, the 2/3 of that, which would be 4 feet, we have to have a 4-foot canopy awning. So if we have an 8-foot window or a 9-foot window, we have to have a 6-foot awning. So it becomes difficult if your architecture is already defined and you're bringing in these principles and using the prescriptive path. But the other thing that's interesting about it is we have actually, just as we're modeling, we've noticed that if we raise our solar heat gain coefficient, we actually have a better chance of meeting some of the standard because we get more heating in the winter. Now, that doesn't mean code, but as you play with the numbers, that some of this stuff is just not as intuitive unless you're kind of really familiar with it. But it always depends on the design of the house and the comfort and just all your assemblies and everything else going into the model. But every little thing you do matters.
Did you say it depends?
I did. It always does.
AJ, you're on. Did you have a question?
There is one question that came into the chat about discussing slabless foundations of the future.
Well, I'll do a selfish plug, but you can pick up your Green and Healthy Maine Homes magazine or go to their website. There's a great article my friend Michael Maines put out there on some slabless slab ideas, and one of our projects is featured in it. But yeah, great way to reduce your carbon impact. Very successful for us in Maine to be doing slabless slabs. Have you done any of those, Chris?
No, no, we like our slabs here. No, I think just like any new design, new technology, anything that's being introduced. I mean, we're doing some things on our passive house here we don't have a turn down on our slab, so we're building this raft slab, continuous 8 inches, and that's a new thing. People are getting to know it, and I think like anything, there is a future for it. But we've been building houses with 2x4s for how long? It's going to be a really long time before we go away from 2x4s, if we ever do. Getting away from slabs, probably not ever going to happen. We can do that on a few projects here. On your project, it can be done. But will we ever go away from it? We've been doing it for so long. And until it becomes something that's just like we cannot use concrete anymore, or some other, extenuating circumstance that says, hey, we have to come up with something else, I think we're always going to see it. But it's another good idea. It introduces components that are in contact with the earth that have to be considered.
I think that's a great point, Chris. And for us at Habitat, I strive very hard as we're doing these higher levels of efficiency and everything, to not add complications to it that our homeowners don't totally see the return on. And I think the slabless foundation is a really great idea and works for some people. And I think the question was like whether or not TimberBat will have any products that are going to be able to come in contact with the ground coming out, and that'd be great if they did. I tend to not want to be the last adopter of something, but usually try not to be the first adopter either. And that may sound overly passing the buck to some people, but mostly just because I'm not building a house for myself. I'm usually building it for other people that they're in need, and they're not going to be able to deal with things that are wrong. So in looking at our future passive houses, I wanted to reduce our carbon footprint, but I didn't want to go to a concrete-free foundation. So we went back to what we had been doing years ago and went back to a simple crawl space with normal concrete footing, a short stem wall, and a normal crawl space that we're able to, air seal in a normal way, not use lots of concrete, use a good insulation down there, but still decouple the house from the ground, but still only have concrete in contact with that. And that seemed like a really good way to attack having less, carbon intensive concrete, but still not be kind of doing it in a resilient kind of normal fashion. So that's kind of where we've moved to as much as we can. And it's kind of like how we do basements. We do basements when we have to, but we're not I'm sure you see that a lot, Randy, up north, but we are in the climate zone where we don't do basements a lot, since we don't have to dig down for frost line. But as Habitat, we get a lot of plots of land that are very sloped. Basically, nobody had built on them because it didn't make sense for them, but then we get them and we'll build on anything. So we end up doing a lot of basements for that reason. And that's kind of how we treat these crawl spaces, is use as little concrete as possible. Don't do a slab if we don't have to, and try to. I'm also super excited for that person that asked to hear more and more about some more less carbon intensive concretes, and having that be more good for our environment coming out. Because I don't know that we're ever going to get 100% away from concrete. It's just a great thing to build with, strong, durable, and is, like you said, we're not going to get away from 2x4s, but using them in an effective fashion really works out good, and we can do the same thing hopefully with concrete.
Yeah, we're seeing that similar crawl space idea become more and more up here. in the climate and eliminating basements. Everybody had a basement up here, but now it is going away, and that's kind of cool. And doing the crawl space is a great approach also. So
Another
I'll get back at.
question.
Oh, go ahead.
Another question came in about, does Passive House account for embodied carbon from materials or the overall project? Or is it specifically design parameters?
In short, it's all about energy. I mean, not all. It's not all about energy. The energy is the focus. I have a couple slides that'll show that, but there's nothing specific about like we're not entering, we're entering material types, not entering product specifics, you know, to know exactly how much carbon footprint each product is. There's not an output. There's not a measurement tool in Woofy Passive. It's all encouraged to use materials that have that, but there are no requirements that say you have to. So this isn't the program for the specifics of reducing your carbon footprint. The benefit of doing a house like this, in many ways, you get a much lower carbon footprint, and it encourages the right materials for that too. But
less on the operational carbon versus the material.
Yeah. I mean, this one is geared mostly toward comfort, energy, and air quality. I mean, those are sort of the primary three primary things that this does.
And I think this touches though on the idea that Passive House can lead to other things much easier. So this pre-planning that goes in ahead of time when you're building a Passive House really makes you think about your materials more than traditional building. So it's easier to enter that data into like a beam calculator and get your carbon information for it. It's easier for you to reduce your loads enough to go to net zero. It's easier to utilize some of these other programs as well. So, but I think that just goes back to the planning phase of things and your design and your optimization with designing a Passive House. So you use computer modeling to do that. And this is just a quick screenshot. And I know Chris is going to talk about it a little bit more, but the idea that we enter that data into computer software, and it will give us a result of how our building is going to perform, and it really allows us to optimize our building too, both energy consumption but also budget, because if you can quickly model a couple different changes to, you know, a part of your envelope or a different type of window, you can really kind of value engineer a building pretty easily, I think. So that pre-planning, I think, is one of the huge things I like about Passive House, and that ability to start thinking about the build before you're actually in the middle of the build. So. But again, I think, and we've all kind of hit on it, why do we do Passive House? Is because we're creating resilient buildings that are going to last much longer than other building types. They're going to be way more comfortable and just very healthy for both the building and the occupant, because we are thinking about all that stuff up in front too. Then we also start thinking about those materials, the carbon impacts, the off-gassing of materials that we're selecting indoors and all that type of stuff. But as a result of thinking of those three things, we really end up with an efficient and an affordable home to operate. So those are, in my opinion, the byproducts of building Passive House is getting an efficient and affordable home. But the main goal is to build resiliency into our buildings and that comfort and health, which those three things are hard to put a value to, right? Or associate, you know, some sort of money to when you're building and what those things could cost. But so, and yeah,
value
so
is the
just
key
many
word.
of the-
I'm sorry. I was just going to say value is the key word there, Randy, that we obviously, like anything, everybody's asking about cost. Is there savings? BS has done a study and said that this is actually only a tiny percentage more than standard construction. Many people disagree with that. It all depends on the project and how you approach it. And, you know, you could maybe be 3% more, but in the end, who does it value? What is that value? And then you kind of build from there, and sort of your goals in terms of performance and costs are all based on that value. And okay, well, spend it now and then never have an energy bill, or spend it now and never be sick again. You know, that sort of, those kind of values are hugely important in the beginning.
Right. And I think it until you actually experience it, you can't realize those benefits. But I think the first time that you go to bed and wake up the next morning in a passive house, you feel different. And just walking into them half the time, people really notice just the difference in being able to breathe and being a little more comfortable. So I think experiencing, creating more experiences for more people, I think would really go a long way to adding that value. But
And Chris, you brought up a really good point too, and I wanted to ask Dan, because he's obviously building houses for a budget, a low budget. So what do you find are some of the things that you're doing that make it capable?
Yeah, so
Possible?
the first set of passive houses that we did, they were the first ones in DC, and that's going on, maybe 10, 12 years ago now. That one was a strenuous build. It was complicated. And whenever you add complication, there's expense with that. Now, the nice part about Habitat is most of the people on our job site on a given day aren't billable hours. So it's really just me and a couple of people who have salary. So it took us a lot longer. And our push since then has been to weed out the things that were not. So there were lots of different designs, aspects of that first one, because the reason we got into it was for the solar decathlon, a university came to us and said, we're designing this. We'd like to actually build it for someone. Great plan. So they designed it, in real out there thinking good building practices, but it was pretty complicated. So the next 6 we did, we scaled that back and we made them look much more like our normal townhouses, more standard details like what we did before. But they were the first time that we were really in the design as much. And so we kind of pushed it and did belt and suspenders on everything. And that was great, but again, it had extra costs. And so the next 17 that we're designing right now, my goal was to be able to do a real apples to apples comparison of this is what it will take us to do. And the FIAS criteria has honestly changed over that 12 to 14 years now. Like, they've made it a little bit more climate specific. There's a prescriptive path now. There's things that can make it a little bit easier for you to kind of dial in your costs, so that if you're like, for us, for a lot of passive house builders out there, they're building for a different client each time. So they might be able to standardize their wall type or some details, but they're going to have a different house all the time. The advantage for us is we're much more like a track builder in that we have to design for our site, but we control the design. So if we can dial in what works for us, what works for getting passive house certified, and I can dial in those costs, then I can make a real apples to apples comparison. And my goal for that is that then I can put that in front of sponsors and the city for grants and things like that, and say, if you give us this amount of money, we can go from what we would normally build to a passive house. Because it is hard, like I think Randy or Chris were saying, it's hard to get real apples to apples comparisons on that, because every build's a little bit different. And like Chris was saying, if you take a passive house that you didn't plan, a house that you didn't plan to be passive house, and then all of a sudden you try to do it passive house, you're going to spend a lot more money because you did not plan accordingly from the get-go, and you're going to end up that's going to end up costing you. You're going to throw money at the problem. Whereas if you start at the beginning, like we were talking about, and do that planning up front, well, then you can tailor. You can say, oh, do I really need this, bay window, or would I rather have this, and dial in your costs, or no, I really do want that. That makes the front of the house for me. It's worth the extra intricacies and costs and stuff like that. So you can make informed decisions, not just about your energy, but also about your costs of the build. And so it's very hard to compare one build's cost to another build's cost without having had them go through the same kind of program and planning throughout it. And so
And at
that's
the
something
same
that I'm
time.
trying to get figured out.
And it has to go, it has to be like at the same time and right next door to each other, and to see, like, they have to be exactly the same to really get that comparison, because we've designed and built houses that are, maybe they're just high performance or just passive but not certified. And the question always at the end is, what was that compared to just, what if you had built it to code? No clue. There's no way to know. I'd have to build them both at the same time with the, getting the same price for lumber and everything at the same time.
And
so
and
it's a
and
tough
that's
one,
why
but you can estimate.
the numbers, you could take it and design it in your head, and you can map out the materials. But honestly, in my experience, the material costs of a build are not what make my budget go out of control. It's those planning things that were not planned for in advance, that pop up, that were not thought of. And now the way to fix it is you throw time and money and energy at it, versus if it's planned for and all that, there are extra material costs. If you're going to go passive and you're going to put, more insulation in the wall, that's going to cost you more. But those are really calculable and planned for added costs, and you're going to get the benefit back from that. I have no question about that. It's those unintended things, and that's the case whether it's a passive house or a code built house. And that's why I think one of the big benefits for us as far as going passive house is, they hit on it. You have to go through a design review. Most of the other green building standards that we do, it's just a checklist, and they're good. They help you build a better house, but it's beholden on you to make sure that you do that design up front. Whereas one of the great things about the FIAS and PHI program is they want to help you. They are going to look at your designs. They're going to critique them. They're going to give their expertise, because they want, if they're going to stamp it and approve it, they want it to be a successful home and successful build as well. And so getting that forethought and getting knowledgeable people's eyes on it before you ever step foot on the site, I think is really one of the major benefits.
That's the one thing that we preach in a lot of our trainings is just pre-planning. Even with the code built home, that pre-planning and understanding where all your control layers are and how they're making their connections, because that really makes the difference. And then I think it'd be, I think you kind of touched on it too, but repetition. Like, we've been building houses forever one way, and we're quick at it because it's repetition. So until we're effectively, more people are doing this and they're doing it repetitively, then it will also gain some more additional advantages, I think, in cost. I know, like, the first house that we ever did, definitely took way longer to detail out than they do now. Now it's just second nature. We don't think about those details. They just happen. So I think that's kind of cool.
Awesome.
And this will kind of kick it over to Chris. So if Chris wanted to discuss how different climate zones affect, when what
Yeah.
you're doing.
What are all these calculations that we need to put in? What does it even look like?
What does it look like? Let's see.
Boy,
There's so much that I can so much to cover, but let's just do something. Let's just see what we can get here. So when you start a project, you have to know your targets. Okay, so in targets, the main criteria for targets, you start off with an envelope area. So you've designed the house, you have a shell, you know what your envelope area is, you know what your square footage is. You pick your location, and it spits out the space conditioning criteria that are used as your targets for the entire process or the entire modeling process. Okay, so if you hit these targets or less, then you will pass. Then you will meet. You will meet the target. You will meet the program. The one thing that's constant all the way through is here. Well, given that the envelope area and square footage are the same, and your dwelling and total number of bedrooms, no matter where you are in the world, your kilowatt hours per person per year is exactly the same. So the only thing that changes that is the number of bedrooms. So if you increase the number of bedrooms, that kilowatt hour per person per year goes down. Okay, so the total amount of energy consumed is what they're looking for, right? So the criteria, what we're trying to get is climate data. So that's another thing we have to enter into the software, is to let us know what our climate data is based on an average of usually 30 years. These are typical, this is typical climate data. This comparison here, this is showing a project that we're a consultant, a passive house consultant on in Chattanooga. So you can see here that we go from 4 to 12 bedrooms, just as an example. You see that kilowatt per person per year goes down. So this just the only thing that changes there, that changes that number. So you enter these targets into the software, and then that's your guiding factors there. So once you have these factors, then you design your building envelope based on trying to meet that. You have good air sealing, good thermal control layer. You get all your moisture, your water, air, and vapor control layers. Designing your whole assembly, and then here we have, this is sort of conceptual, where you have all your control layers to the outside of the structure. And here is a site-specific one. This is the Chattanooga project we're working on. We did both cavity and exterior insulation. But the ultimate goal here is, let's make sure that this perfect wall is continued around the entire structure. So once you have your building envelope, you look at hygrothermic analyses, which tells us, what's the moisture risk of these assemblies, these perfect walls, to make sure we don't put our assemblies at risk. This is something that FIAS will ask you to do if they don't have full confidence that one of your assemblies is going to fare well in that weather, in that climate. Maybe too much exterior or not enough exterior insulation and too much interior. If you have the wrong balance, you're going to get condensation in the assembly that will cause damage. Other things we have to consider, if you use continuous insulation over a certain thickness and you have metal furring strips or hat channels or something that is in contact with your metal fasteners, you have to account for every single one of those fasteners. So this is a calculator that helps us know how much we have to reduce the R value of the assembly for all of the walls, the roof, wherever we have these fasteners. And I'm only sharing this as an example of some of the nitpicky stuff that we look at everything. The other thing is windows. We build the windows literally.
When we were doing Andy's place, I remember we were doing like 17-inch screws on his roof, and they were stainless steel. And although
stainless steel is like Yeah, we've done 8-inch insulation, 10-inch screws, 11-inch screws, and we didn't have to account for this because we had wood furring strips, and there were a lot of things go into this. But with stainless steel, it's about 5 times the cost or more than standard carbon steel. So that's another factor, but it reduces that thermal bridge or that heat loss, tremendously. And then if you use, I mean, those are really the 2 main options that are commercially available. So these are the targets. This is go ahead.
One more quick thing. And I know, well,
Yeah.
talking about limiting screws too, Randy actually had it run through an engineer, I believe, right, Randy, on like how many screws per, vertically on a furring strip, and even angling some of the screws up to hold.
That's right.
So then you're not just zapping in a bunch of screws too.
Yeah. Depends on the cladding, depends on the whole, whatever, like if you're doing super heavy cladding, then there are screw patterns and just all that matters. Yeah. So basically you've built the model. I mean, so much else goes into this, but I want to give just a quick overview, but you get here are your targets. This is the target, or this is the target here underlined. And then this is the specific, which is to the project. So this gives us an idea. We're using 1,000 kilowatt hours per person less than the target. So this, you can see all the check marks here. That's a good thing. So those are some. Let me just jump over to stop, and I'll just show you the software really quick because there's some interesting things there. I just want to show this, speaking of air tightness. So this is what our Woofy passive software looks like. This is the Chattanooga project. But right here we have 0.05 CFM per square foot for air tightness. And that's basically about 0.5, 0.6 ACH50. If we double that to make it 1.2 ACH50, everything, we're failing just like that. So this air tightness criteria is extremely important. We've gotten our houses down to 0.05 ACH50, so we tend to use a lower target, and you can see even between 0.03 and 0.05, there's a significant jump there. So these little
Chris,
tiny little things. Yeah.
I would add, in talking about cost, that's the other thing. Airtight, sure, tapes and things like that cost money. So what I'm saying is not 100%, but essentially airtightness is free. It's attention to detail, planning, and doing things the correct fashion. Because since we built passive houses, our non-passive houses are tighter too, because like we've been saying, if you get in a routine of doing things a right way, of not passing that cantilever just out and not fully wrapping your air barrier all the way around, and just the good practices to keep things airtight, that stuff is free. And makes such a huge difference in the performance of your home.
It does, and we've told most of our clients when they're looking for high performance, and we're the bearer of bad news that no, it doesn't cost the same to what. When you look at Joe, when you look at our details, you look at what's being talked about out there, people come to us and say, I want a house that Joe Stiebrick would design. Well, no, you can't. No, you don't, because you don't want to pay for it. And we've designed, they look at our past projects and say the same thing and say, I want that. So, well, you don't have the budget. The thing we always turn to is, if you really want the high performance, you just focus on air sealing. I don't care about insulation I don't care about the insulation yet. Give me a super tight envelope and get the ventilation balanced. That gets you, as you can see with air tightness, that much makes a huge difference on the performance and comfort level of your building. So to your point, it's like, it is, most I've ever seen it spent on a house is 1% of the construction budget to increase the air sealing package. And all they did was buy thousands of bottles of caulk. At the time, that's about all that was available. was some caulk, and they just went around the entire building and just air sealed every single gap. Never smelled or seen more caulk in my life, and I don't want to ever again. Seal from the outside.
It's probably too, the software is probably not able to model what code air changes would be. That would just be scary.
Well, I mean, I mean, that's the thing. So 3 ACH in Georgia were 5 divided by 0.06, so that's 80. Oh, I don't know. What I did that wrong. But if so, 1 point. Let's just put it up to 3. I mean, there's nothing. I mean, it just happens so fast, right? So anyway. The windows, like I said, in the windows, we're entering all this data from the frame, from the glass U values, the solar heat gain. That's just this is anyway. These are just the U value of the frame, the U value of the glass, every little bit, and how the glass meets the frame. So all that stuff is crazy. And one last thing that's sort of interesting here. Of course, we're calculating all the water heating. One cool thing about this project is it gives us an idea of how much solar we might need to get to 0. And it's usually pretty accurate. So it's somewhere around 9,700 or something. Anyway, you enter the kilowatt, the size of the photovoltaic system here. And when this equals out to 0 down here, site energy and source energy, that tells you how much. Basically, you can tell your solar contractor, okay, we're going to target about this, or for budgeting purposes, you don't have to get them involved yet. So that's just another cool thing. But there's so much detail in this; it's just hard to go into it. But everything we do matters.
What I learned here is to hire a passive house consultant like yourself if you want to go down the path and get you going down past.
Yeah. That's right. And we've been using this software since, we've been using this software since before we were certified consultants, because the passive building is where the passive house came from. Is you're building passive, and that's just making these buildings resilient and, kind of doing their own work to save energy and to make you comfortable and healthy. So this passive building idea, so it doesn't have to meet the certification. And if you got halfway to certification, you've got a rock star building. So passive is really the goal. Passive house is awesome and fun and gives us a measuring stick, but we can do everything you do in certification without getting the certification, which can cost $10,000 to $20,000 more just to certify it. And just the certification part.
I saw somebody asked about pretty good house versus passive house, and I think obviously knowing Emily and Mike, I think some of it's burned out from that of like we want to build really good, but not every client can afford, like you're talking about, the thousands of dollars that certification matters, having those extra sets of eyes, and especially the first time you're doing high efficiency or anything like that, going through a program has really big benefits. So I don't mean to knock that, but for some people, they can't afford it. Well, do you want to just not build a good house? No, you still want to build a good house. What can meet your budget? And like we talked about, they're really based on the same principles, air seal things, ventilate correctly, put in good windows, whether in your climate zone you need to have a triple pane window or not, that depends on where you are. If you're in a southern climate, maybe you don't need to have a triple pane, but you want to get a good casement so that it seals tightly and you get good air tightness out of it. So picking those things where you need to spend your money, I think that's how passive house and pretty good house relate, because not every client is going to have a budget that will maybe go the extra mile, but that doesn't mean you can't build a really good house off the principles and the know-how of having built a passive house.
Principles.
So That being said, and one of the questions that kind of came in, what are some of the low hanging fruit things that we could do in a house? What connection points? What is it? Windows is, buying triple pane windows the answer? Is it, what is it in your market, at least in your climate specifically? We'll start with you, Dan. You were just on.
So I would say the 2 points that we have kind of tried to dial in the most are the foundation to walls connection, and however we're capping the house. If it's a vented attic and all we have is normal trusses with drywall on the underside of it, then making sure that anything that goes through that drywall is well detailed, can light, trying to get can lights out of it, all of those types of things. So, and I have found more and more that the more we can decouple that and not have that, whether it's, just 2x4 for sleepers on the underside, so that, yep, just like you Randy has behind you, to give yourself a chase to do that electrical. We have to do fire sprinklers, bringing those inside so they're not penetrations through our air barrier, because those were really hard and time consuming to detail. So dialing in those two connections, I think the general way that we build houses has does a pretty good job on the walls. Like the way we do, pretty much everyone around us does continuous sheathing, And so if you sheathe your house and it's fairly tight, and if you can convince your builder to do zip sheathing and tape it, you're going to get really good wall air tightness for the field. You might have to look a little bit at the windows, but the little can spray foam that we do around the windows, and doing a pretty good job on that does, it doesn't do as good as we want for passive house, but it does a pretty good job. And then if you do that, cap that lid and that bottom, and that was something I learned from Peter Yost when I took a course from him, that because of the stack effect in our houses, if you do a good job sealing the bottom and sealing the top, the walls are much more in equilibrium. So there's less force pushing on those holes that you have. So you can get a lot more bang for your buck that way. And then the last thing I would say is just the windows. If you can go away from a builder grade double hung window to a casement from almost any of our manufacturers here in the US, you don't have to go to triple pane if you can't afford that. But if you can make that small change, you're going to get much better tightness and performance out of your windows without even having to go to the triple pane passive house certified. I love those windows. Those windows are great and they're worth the money, but not everybody has the money for it.
Well, awesome. Thank you, Dan. You hit a lot of topics there. How about you,
Yep.
Chris? We're in kind of final Q&A and wrap up too. So
I'm quick. I'll be quick.
no, you have plenty of time.
Just simplify and integrated design. If you simplify your approach to the shell, not simplify the shape of the shell, while that helps, it does help quite a bit. But I'm talking about your approach to your building shell, that if you can, as much the simplest way to air seal, insulate, and control all of your unwanted moisture is to do it all in one location, and that's all to the outside. The method you were just hinting to, or talking about, Dan, kind of addressing things from the inside, becomes sort of an origami of surfaces and things that become complicated. So simplify by pushing all of your control to one spot, get it all done on the outside, get rid of your overhangs, because if you don't need them, if they're not really doing any protection, there's a whole discussion there. But this integrated design, no, I'm not going to do it. Thank God Travis isn't here. But integrated design is making sure, you're getting all of this. We do the HVAC design and all that on ours, but that's not always the case on projects. But to get everybody involved early and plan the whole thing to make sure you don't need them. Then get everything inside the building and avoid having some of these some of these things. And those are, to me, those are two things that those are just different approaches. They're not necessarily more, it's not big budget things. It's low hanging fruit. It can be done on any project and every project.
Yeah, and then before we get over to Randy for final, Paige, you have a question came in?
Yep. Last question is just on vapor barriers. When are smart air or vapor barriers required, recommended for wall assemblies, especially thick passive house insulated assemblies? So like when or how do you know?
Should we all say it in tandem? Ready, Randy? 1, 2, 3. It depends.
It depends.
So basically, it's a matter, typically passive house, when you're using a lot of continuous insulation on the exterior, by code, you won't need a vapor barrier. If you're using that vapor barrier as an air barrier, then it could be a secondary air barrier. But other than that, you have a primary air barrier and a secondary air barrier. In these high performance designs, I don't even think vapor, you really need to worry about that because you're so building so far out and conditioning that sheathing, even in Maine, double stud-wall system, maybe then yes, you do need a vapor control. But again, it depends. So
yeah, and the number one thing I've always learned is always have an air barrier and continuous. As far as for vapor stuff, if you're talking an actual vapor barrier, 1 is okay, 2 is very bad. So don't sandwich stuff between 2 vapor barriers unless you are really sure that it's not going to get wet, because it won't be able to dry out. Usually we're talking about retarders, vapor retarders, that can control vapor but aren't just a dead stop. Barriers are you got to really know what you're doing, and if you're going to do it, you want 1, is my experience.
Yeah, that's the question asked about smart air also, and that's, yeah, you could use that anywhere that you would like.
I want to say that I don't know, because nobody knows. Nobody knows for sure. It is a site specific. It's very specific to the assembly. What Dan said could be true. It could be completely. It could be terrible advice. If somebody, I don't mean that on you, Dan. You're super smart.
No, I got you.
I just mean I've done, both Dans. But the thing about it, like every location and orientation matters too. So the same assembly that works facing south could be horrible facing north. So you got to understand that as well. So I showed a hygrothermic analysis, chart earlier, or a result earlier, and that is a drying potential modeling that shows us that in worst case scenarios and averaged over an entire year, how that assembly will perform and where the risks are, and whether the sheathing will get wet or whether the insulation gets wet and whether it can dry out. That's what you need to know. That's what you need to start with, and just understand those things before anybody can answer that question, because there's no one answer that fits all on that question. But we just have to understand what's going on first.
And then I'll go final thoughts with Randy, and then I'll end it with Paige.
So I think my biggest thing coming out of any of this is always just planning. Pre-plan, have conversations with your trade partners, get everybody on board ahead of time. That's all I can say, and that's the most successful way to execute, and earlier the better. But to Dan's point, simplify above, seal the top, seal the bottom, makes a huge difference.
Yeah. And how about you, Paige? Did you have anything?
No, I guess just kind of, if I could mimic off of what Randy said, just plan ahead, take your time, make sure everyone's educated on the same page, and use resources that are out there. Ask the questions, look at, different assemblies, and figure out the one that everyone's comfortable utilizing for the first time that fits, your climate zone.
Yeah. And even feel free to involve your local TimberHP rep, because we could be of service. So Paige, she's up in the New York State area. So, but yeah, so that's pretty much all. We're wrapping it up. We hit our hour mark. I did want to definitely thank our panelists, Dan, Randy, and Chris. You guys were awesome. Thank you very much, Paige, for being in the background and popping out every once in a while with some really good questions, and just being an expert out there as well. So I guess
thanks for making this available to everyone too.
Yeah, and for those that, I mean, obviously anybody on here now has watched the whole thing, but all these are on our YouTube channel as well. And I know, Dan, you actually have to go run to a BS and Beer Washington, D.C. event. So if you're in the D.C. area, Atlas Brewing, 7 p.m., you can go meet Dan.
And if you're not in DC, look up your local BS and Beer. Even if you don't like beer, people come, drink wine, whatever. I love beer, but if you don't, you're still welcome.
Yep.
Great community.
Awesome.
Wait, just before you go, one more question, and it's based on all of us, I guess, technically. Who has the most years of experience as experts in this game?
Oh goodness.
I've never been.
It's not going to be me. I'll say I still don't consider myself an expert.
I will say that I got into the BS game when I was born, but that's a different BS. I started working for Allison Bales back in around 2010 and have never left. I mean, brought it into, that's where sort of the focus on building science started. And then he and like others became mentors like Joe Stiebrick and John Straub and all those, and the ones you've mentioned as well. So maybe, I don't know. We've been doing it that long. So that's at least 14 years.
Yeah, for me, I started in Better Building by Design in 2014. I started down because I wanted to learn more. So 10 years.
I built a LEED building in 2009 in South Carolina, and that was my first real introduction into energy efficiency building for Habitat. And I got the itch, and that's part of what brought me here to DC, because they were starting the first passive house build in DC, and I think that was in 2011. And I've loved doing it ever since. But my thing on that question is there's always somebody that knows more than you, but there's usually always somebody that knows less than you. So be free to pass your knowledge down, so that those that are lower can pick it up. That's how I've gotten most of my education in this realm.
Yeah,
How about you?
I was gonna say, I was gonna say, that's one of the greatest things I think about this entire building science passive house world is the idea that everybody's just willing to share and pass their knowledge on to somebody. So always just reach out and don't be afraid to ask the question, So, but I got interested in
sorry, yeah. I was just saying what you were saying, Randy, that we all lean on each other, and whenever there is something different, and whether it's just bouncing an idea off or just confirming what we think we know or what we just told somebody so we can save our tails. We always are, it's a network. It's one, sort of communal mind.
And how about you, Paige? You're an expert too.
Well, learning every day. I guess probably since what, 2014 with you? 10 years?
Yeah, probably Better Building by Design. I think
Yeah,
you were
like 12 or 13
2015.
years in the industry.
Yeah.
Did a little lead with Boral back then, but I had no idea what I was talking about. So yeah, about a decade, I guess.
Yeah. Well, awesome. Well, thank you very much, guys. And yeah.
Thank
We'll
you.
see you
Thank
next
you,
time.
Paige.
Thanks, everybody.
Thanks,
you, everyone.
everyone.
All right. Take care.
Bye.
Bye.